Most programmers who do that for a living don't write code alone. You almost never write code by yourself. You never write a program from beginning to end with nobody else helping you. And most programs in modern times are way too big for stuff like that. And so usually programs are written in a modular way. They're broken down into modules or functions, right? And so there are inputs to that function and an output to that function. So a manager would tell a programmer, say, hey, write a function that does this. It takes these inputs and makes this output this way, right? And so that's normally the job of a programmer, is to write modules or functions. We're familiar with functions already. We have math functions, and there's printf and scanf and things like that. And so many of them are already written and put into libraries for us, but sometimes you need to write your own functions. And that's what we're going to learn how to do today. Right, we could start with an existing program like average_argv, but I'm going to start from scratch to sort of show you the skeleton of how functions look in C programming before we add all the functionality from another program. So I'm going to start from scratch, make a skeleton program, and then open up average_argv and stdev and copy functionality from those programs into my little skeleton here. That's what we're going to do. In order to start, I'm going to get the command prompt up. So I go down to the search bar, I do cmd, I get the command prompt. Then I cd into OneDrive, and then I cd into desktop and cd into C code. Then I do make project.bat space, and then the title of my program here is going to be mod_avg_std. So it's a modular program that's going to make functions both of the average and of the standard deviation. That's how I came up with my little project name. Good so far? Okay, so then I go into File Manager, I find that folder, I double click on the C file, and it comes up in Notepad++. Before I add anything from any of these other programs, I'm going to start defining the functions. There's a few ways to do this, by the way, a couple really, and so I do it one way. I'm going to explain why I do it that way, but recognize that there are more than one ways. There's more than one way to do this. What I do is I have above main, I have declaration statements saying, okay, I'm going to make a function. I'm going to call that function calcavg. And I put that declaration statement above main. This tells the user and also the compiler and saying, hey, okay, when you see these functions in main, this is their format. This is how to call them, right? Right, and then below main, way below main, I'm going to give those functions what's inside, the contents of those functions that actually does the operations that gives them their functionality. Right, so that's the format that I use. What you can do is you can define the function and everything all above main. I don't like to do that. I like to put all the functionality, all the details below main, because normally somebody who's a user, another programmer is going to look at that code and say, okay, it's calc average. Okay, that's a program that calculates the average. Most of the time, you're never going to need to see the details of how the person calculated the average. You might, like with standard deviation, is saying, are they divided by n or n-1? Is what type of standard deviation are we talking about? They might want to go in and peek at the details, but most of the time, for most functions, you don't really need to know the details, just the input, the output, and read what that function does, and you got it. Right? I don't know how most functions in C that are in all the libraries, I don't know how that most of them work. I just trust that whoever wrote those did a good job. Right? So that's how I do it. I just give the declaration statement so that users say, okay, there's two functions in here, and this is how you call them. The first line of each of those declaration statements is a variable type, float, int, etc. And so both of these functions are going to return a float value. That's what that float means. It's what is the return value of that function. So on the left-hand side of the equal sign, when I call this function, what type of variable has to go in there? The compiler is going to check on that, right? So you have to make sure that's right. Then inside the inside the parentheses are a list of the input arguments. You have to tell the compiler what type of input arguments you're expecting. So the first one is a floating point array, a underscore n with open and closed brackets with nothing in them. What happens is when the function's called, the C compiler is going to make that a underscore n the same size as whatever array is coming in. 10 points, 100 points, 1,000 points, whatever. So that's why you leave that blank. And then comma, int npts. Notice I didn't say a and n. That's been the variables names that we've been using up until this point in main. I didn't do that. You could, if you wanted to. The input arguments to functions are sort of dummy variables. They're copies of whatever's in main. So you can use the same name, a different name. It doesn't matter. You just have to say what type of variables they are in there, and the types of variable has to match whatever you're going to put in them from main. That's the main detail. But what they're called doesn't matter so much. You're just going to, the function is just going to get a copy of whatever you're going to put in there inside of main. Okay, and then there's a semicolon at the end. So I did that for both calc average and calc stdev. Then I highlight the declaration statement, that calc average declaration statement. I copy it, Control C, then I go to the bottom, below main, below the curly braces of main, after return space 0. And then I paste it down there. I take away the semicolon and I add curly braces. The last line of a function is the return statement. So I'm going to return, and then I'm going to return the variable that I want to return, average. I'm going to calculate the average. So I say return space average, average, semicolon. In order that it doesn't give you an error, you have to declare that variable inside of this function. Float space average at the top of that function. So that's the skeleton of a function. Then in between the float statement and the return statement, we're going to add all the functionality in order to be able to actually calculate the function, calculate the average value for that function. Good. Same with calc stdev. I'm going to copy that declaration statement at the top. I'm going to paste it below the closed curly brace of calc average. And then I'm going to take away the semicolon, add curly braces. I'm going to return a variable called stdev, semicolon. And then at the top of that function, I'm going to say float stdev, semicolon. Okay, that's the skeleton structure of a main program with two functions in there. Okay, now I'm going to add functionality. I go into average underscore argv. I find that in Finder, find the average underscore argv.c program. I'm going to take the first part of it. So I take all the declarations, the declaration of variables there, and then I'm going all the way up to the end of the file input, n equals I. I'm going to take that, I'm going to copy it, and I'm going to paste that into main of my main program. In my main program, you don't need sum, right? Because sum is just a detail variable that I needed to calculate the average. But that's all going to be done down in a function, so I don't need that in main, right? So I'm going to cut that line out. And then at the bottom, after I've loaded all the data, I'm just going to say avg. That's the variable name that I'm going to use inside main. It's not the same as in the function calc average, right? Is it? That's okay, right? So I'm going to make a variable avg in main, and I'm going to say avg equals calc avg open parentheses a comma n semicolon. And so that's all you need. You don't need the for loop or anything like that. All that's going to be outsourced down to the function. Then I go back into average underscore argv and I take the functionality part, the calculating the average part, and I put that in, I copy that and I paste that down into the function calc average, right? I have to add int I, there's an I, right? I need an I counter. Again, the local I counter in the function main has nothing to do with the main, the I that's in main. It's all local. It's all a local variable. Then sum, I need those, and then I look through the code, and everywhere I see an N, I have to change it to NPTS, and everywhere I see an A, I have to change to A underscore N, right? So I have to change all those variables to make sure that it's going to work right, and then that's okay. Same with calc stdev, right? I have to, I'm going to get the functionality from that from stdev.org. I'm going to copy the average part from calc average down into calc stdev. I could have gotten it from calc stdev. I could have gotten it from stdev.com too. It just depends, you know, and the way I did it this way, I didn't have to rechange a_n and npts for that part of it, right? For calculating the average part. I didn't, I could have, if I wanted to, I could have had the average value as an input variable, or inside of calc stdev, I could have called calc average. I'm not doing that. I'm going to calculate the average again. It seems like a waste of time, but early on, when you're writing functions early on, it's best to have all of them be sort of standalone, not relying on any other function, right? Advanced programmers, they write libraries, right? And so those libraries have all sorts of dependent functions. And so when you're independent, if I want to import just the standard deviation function, I'm just going to copy the function itself now. But in the real world, you would have made Lars's library, right? And so I would have my own library that has that and average and all that stuff. And then you can have dependencies and all that stuff. But early on, when you're just writing functions only, it's good to have each function be standalone so you don't make a mistake or anything like that. You don't know, well, how many functions do I have to copy? Just if you only need the stdev, only copy stdev. Only copy the calc stdev function. You don't have to copy the calc average function with it. So it's a little redundancy, but early on, that's a more robust, less error-prone strategy. As you get more sophisticated, of course, dependencies and all that stuff for functions are the norm. All right, so so I added the functionality to calc stdev. I made sure that all the a's are turned to a sub n's, and all the n's are turned to npts's, and I made sure all that stuff is good for the function part. I declared all the variables, sum, I, and average up at the top, and stdev. So that all looks good too. So now I go back into main. I define a function, a variable float s for the sample standard deviation. Below that, the calc average command in main, the call in main, I say s equals calc stdev, open parentheses a comma n, semicolon. Then I print both out, and that's it. That's how that works. Notice that there's still a lot of details in main. You still have to open the file and do all that stuff. And you could envisage writing a function for that as well, right? But the main guts of it are now just two function calls. It's much more clean, and it's much easier to understand what this program's going to do. So modular programming is, especially from looking at it from the main standpoint, it's way more elegant and easier to understand what a program does when you write it in a modular way. Okay, so I save it. I save the program. I go in. I make sure that the 010, 000, and 0,000 files are actually in the directory that I'm in. So I go to data and I get them and I grab them and I put them in there. And then I go back into my command prompt and I compile mod underscore avg underscore std. And then I run it 3 times with each of the 3 files, and it gives the right answer, and everything's perfect. So it works just fine. We learned a lot. The main thing we learned here was how to write a function, how to organize your whole C program so that where the function calls go, where the function definitions go, and all that stuff. That's an important detail to know.